Hi everyone, in this video we are going to see a practical example of TDD. In my previous article, I have discussed about the test-driven development methodology. This video is a continuation of that article where we are going to see TDD in action. For the purpose of this video, we are going to develop our own custom implementation of a list data structure where we will be able to add and get the integers to and from the list. So let's start with the list class. I'll name it my list just to avoid the collision with the existing list data structure that we have in Java. The first and foremost thing that we need to do is to create the test for this class. We are not supposed to write any production code unless and until we have a failing test case. And remember one thing, that even the compilation error is considered as a failure. So let's create a test for this. So we need to think of a simplest test case that would fail, and the simplest test case would be just to initialize the list and check if the size of the list is 0. So let's start with that. When list initialize, then size should be 0. So my list is equal to new my list assert equals 0 list dot size. So let me split the screen here better. So as we can see here, the size method does not exist, and because of that we have a compilation error. So we have an opportunity to write the production code here. So let's create this method size. And remember one thing, while writing the production code, we are only supposed to write the amount of production code that is required just to pass the currently failing test cases. So what do we expect here? We simply expect that our test case, our size method should return 0 because our test case expect the size to be 0. So once this is done, we'll run the test cases and see if everything passes. Yeah, so it's kind of weird, but this is the right thing to do. We are only supposed to write the amount of production code that is sufficient for passing the currently failing test cases. Let me have some space here. Yeah, better. So what would be another test case that we can think that would fail? Another one would be, after creating a list, let's add an item to the list and see if the size gets incremented by 1. When item added to list, then size should increase. So here we are going to have the same code here, and when we do list dot add, let's say we add 10 to the list. Now we expect the size to be 1. So here we have a compilation error, and again we get an opportunity to write the production code. So let's create this method. Now just to make these both of these test cases pass, we actually don't need to store anything into the list. We just want that whenever the list is created, the size should be 0, and whenever an item is added, the size should be 1. So that's all what we want. So what we can do here is we can have a field called size that can be initialized to 0, and whenever an item is added, we just increment the size, and instead of returning hard-coded 0, we will just return size, and let's see if both of them passes. Great. So what would be another test case? Let's add multiple items to the list and see if that test case passes. When multiple items added, then size should increase. So instead of adding a single item, we are gonna add, let's say, 3 items, 10, 15 and 20, and now here we expect the size to be 3, and let's see if all the test cases pass. Okay, so all the tests are passing. So in this case, we don't have an opportunity to modify the production code. Unless and until we have any failed test case, we are not supposed to write or modify the production code. But let's take a step back and refactor this current test cases. So we see here this, we are initializing the list here, here as well as here. So instead of initializing the list individually or separately in each method, what we can do is we can use before each annotation of JUnit 5 and we can say list is equal to new my list, and we can have a definition my list here. Let's make it private. Okay, so here we can just get rid of this, then we can get rid of this and this as well. Yeah, so it's better now. It's better because, say suppose this list and you want to provide the generic support, in that case only one line of code would be modified. We don't need to modify each and every existing test case. So we should take time to refactor our existing test cases and make sure that we don't repeat ourselves. Now let's move ahead. Now after adding items to the list, what we want is to be able to retrieve the items back. So let's write another test case for this. When get item, then item should be retrieved. Okay, so we'll just simply do list dot add 10 and assert equals 10 whenever we do list dot get 0. So whenever we are going to retrieve the first item in the list, it should return 10 because we have added 10 here, and we have a compilation error here, so we get an opportunity to write the production code. Let's create this method, and just to make sure that all the test case passes, we just need to return 10 here and see if everything is fine. Yep, everything is fine. Now instead of adding single item, let's add 2 different values and see what happens. So the first item would be 10 and the second item would be 15. Let's see if this passes. Okay, so the test case is failing, so now we have an opportunity to modify the production code. So this is actually the place where we are supposed to store the values which was added in this add method. But before that, let me just rename these variables. I'll say it is an item and this is an index. Okay, so to store these integers, we'll have a simple private integer array called, say, items is equal to, and let's initialize it to say 10, and whenever anyone adds the item, what we can do is item of size is equal to item, sorry, it has to be items. Okay, and instead of returning hard-coded 10, what we can do is items of index, and let's see if it passes. Yes, it does. So this is working fine. Now let's think of some other test case. Let's say we want to add a lot of items into the list. We know that the size of the list is 10, and we also know that if whenever we are going to add an 11th element to the list, it's gonna fail. So before modifying the code, let's write the test, and let's write a failing test. Public void when add a lot of items, then all should be retrieved. Oops. Yep. So let's say a count of 0, and while this count is less than say 100, we'll just list dot add count and count plus plus. So this will simply add the items to the list. Let's reset the count to 0, and while count is less than 100, again we can simply do assert on count and say list dot get count, and here count plus plus, and let's see if this thing fails. Yes, and as expected we are getting an array index out of bounds exception here. So what we need to do is whenever this limit is reached, whenever the limit of this 10 is reached, we need to increment the size of our array. So first of all, let me take this out, and let's call it min size. And once this is done, what we can do here is if the size is uh, items dot length -1, because the length will start from 1 and the size will start from 0, what we can do is items is equal to, now what we need to do is to increment the size of the list as well as the copy the existing contents of the list. So we can use here arrays dot copy of items dot length into 2. So let's make it twice the size, and I think this thing will return as it is, and yeah, I think this is fine. So let's run all the test cases and see if everything works. Yes, so everything is working fine now. So this is it about the test driven development. I hope you learned something new from this, and I know there are a lot of different test cases that are still pending, like what about deleting an item, and what about if this index that is passed in the get method is say 1,000, or it is outside the size of the current array. So all those things are there, yeah, but I think those are not going to add anything new to the TDD approach, and I think the overall idea is much more clear now, and I leave those exercises to more interested readers, and if you have anything, please let me know. Thank you.